Let's take a look at this problem from your lab assignment, section 7.4. This is problem number 1. They want us to evaluate this integral, and that's 37 divided by x minus 1 times x squared plus 36. So here we have a complicated fraction, and so what we want to do is we want to break up the fraction into two separate, simpler fractions that would be easier to deal with. So regardless of what's on top, as long as the degree of the polynomial on the bottom is larger than the degree on top, we can break it up to separate fractions. Now if the degree on top is larger or even the same as the degree in the bottom, then you'll have to do some long division. But for now, let's just take this and split it up. And so the first part is going to be a linear factor in the denominator. So with a linear factor, you're just going to have an x minus 1, a divided by x minus 1. Now the second one is an irreducible quadratic. That means you can't factor this, because if you can, then it would be another linear term. So you cannot factor this. This is x squared plus 36, irreducible. And so if you have an irreducible quadratic in the denominator, your numerator will have to be a linear term. And the most general linear term is bx plus c. Okay, so meanwhile we would have the same things in the denominator. And so now we want to combine the fraction. And so if you combine the fraction, if you take a look at this breakdown that we have here on the side, we would essentially find common denominators, right, to find fractions. And so the first one, the common denominator, is x minus 1 times x squared plus 36. So the first one, you would multiply this by x squared plus 36, and that would give you an a. X squared plus 36. It looks like they did a little bit more work over here, so let's see if we can catch up with the work that they did. So that's the first part, and the second part, we would have to multiply this also by whoops let me put parentheses here so it doesn't get too confusing. By x minus 1 in the top and the bottom. Alright, so that's the algebra that we're doing. By the way, this whole process is really just an algebra process. And so there's really no calculus going on here, except they don't teach this in algebra because there's really no need for it in algebra, but it does come up in calculus. Alright, so if we have the same common denominator, then our common denominator, if we multiply this through, we're going to get let's see, if we put all this stuff into one denominator, we will get an a, and then x squared, so this will be ax squared plus 36a, and then this will be the same denominator. And then this one will have to get FOILed out. So we will have bx squared. So let's FOIL it out. I'm going to just do it right here. Bx squared minus bx plus cx and then there's a minus c, or plus c times minus 1, that's minus c. Alright, so let's get rid of this stuff here, and let's get rid of this. And so this is all under one denominator. And this was probably a little bit more complicated than it should have been, because I'm trying to type it all out. But this is what we have with the same denominators. And it looks like they took it a step farther, and then they grouped the terms with an x squared and then the terms with an x. So let's do that as well. So down here, let's put the terms with an x squared together. So I'm going to move this over next to the a, and then I have minus bx plus c, and then here it's a negative or plus 36a, which is the constant. So now I have these two next to each other. I have negative bx plus cx, and then 36a minus c. Alright, so I think that's enough to fill out over here. We factor out the x squared, you get a plus b. We factor out the x, we get negative b plus c, or in this case they have c minus b. And then here we have 36a minus c. Okay, so now that we have that, we essentially would have this whole thing is equal to 37. So let me copy and erase a bunch of things again. Here's what we have. This whole thing is equal to 37, so we can just take the numerators, since they have the same denominators, we can just set the numerators equal to each other. So let's write that out. We got 37 equal to, and then let's write it the way they did, a plus b times x squared. And then we have, instead of negative b plus c, I'll put c minus b like they have, c minus b times x. And then we have plus 36a minus c. And so if we just if we have these two fractions equal to each other, and the numerator, the denominators are the same, then the numerators must equal to each other. Now if the numerators are all equal to each other, or if the numerator is equal to each other, this is a polynomial equal to a polynomial. And so what we can do is we can match the coefficients. So there is an x squared here that you just can't see. There's an x squared term, but it's multiplied by 0. So that's why we can't see it. And then there's also an x term, again multiplied by 0. And then there's a 37. So that way we can match up the coefficients. So a plus b must equal to 0, and then c minus b must also equal to 0. And then finally 36a plus c is equal to 37. So we have 0, 0, and the last one is 37. So now we essentially have 3 equations and 3 unknowns, and so solving for this can just be kind of a free-for-all in any way you can. And the way they did this is that they combined this information where they have c minus b tells us that c is equal to b, and so we have ac is equal to 0. That's actually a plus c. It's actually a plus b is equal to 0, but they decided to replace that with c. And then they have 36a minus c is equal to 0, so they have that here also. Oh, I'm sorry, that's equal to 37, so let's put 37 here. And so we have these two equations, and well, these 2 equations and 2 unknowns, if we start with that. And if we do, let's write it out over here just so we don't lose anything. We have a plus c is equal to 0, and then we have 36a minus c is equal to 37. Now if we use like the addition rule and we add both of these, we have 37a, and then the c's are gone, and then so that's equal to 37. So that's going to give us a is equal to 1. So that's nice, convenient. And then now we plug that back into, well, we can plug it in here. If a is equal to 1, then c is equal to -1. And if c is equal to -1, we know that b is the same thing as c, so that must also equal a -1. Okay. So if you know any other ways to solve for 3 equations and 3 unknowns, linear equations and 3 unknowns, then you can do whatever you want to or need to do. But for now, let's just do it this way, and we have the values for those constants. So let's look back at what it was again. A was equal to 1, so that's the numerator for the x minus 1. bx plus c, b is equal to -1 and c is equal to -1. So there's a -1 times x minus 1, and so divided by x squared minus 36. And what they do here is they break up this fraction. So they have a -x over x squared plus 36 minus, and that same number 1 divided by x squared plus 36. And in doing so, what you get is 3 separate fractions that hopefully would be easier to solve. And so we'll solve the integral one by one. The integral of this is going to give us, if you do a u substitution, this is going to be an ln, and let's use the absolute value because they want us to, x minus 1 plus c. So that's the first integral. Now the second integral has an x squared plus 36 in the bottom, and it has an x on top. And so this is going to be, if you let u equal x squared plus 36, your derivative is going to have some factor with an x in it, and so that's going to be the u substitution that you can do. Now we could do this in our heads. When we do the u substitution, where u is equal to this, du is going to be equal to 2x dx. So there's an x dx here, but the 2 needs to get compensated for, so there's going to be an extra 1/2 there that happens. And then when you do the u substitution, this is going to be 1 over u du, and the derivative of 1 over u du is ln u. So this is ln of u, but u was going to be equal to x squared plus 36. And so that would be our second integral. Now our third integral is a formula. It's actually the arctan. The 1 over 1 plus u squared is an arctan. This isn't quite 1, and so if you want to do some sort of other substitution there, you can factor out a 36 in the bottom. And what you'll do is you'll end up with 1 over 36, but then you'll have a 36 factored out here, so that would be a 6, I believe. Well, maybe we should do this a little bit more carefully, because you're going to have some extra constants floating around. So let's do this integral. This is the integral of 1 over x squared plus 36 dx. And my suggestion was to factor out a 36 from the bottom. So this is going to be 1 over 36 that you can factor out, that's sitting outside. And then we have 1 over, now our denominator is going to get a little bit more complicated. It's x over 36, but it's actually 36. We want to write it with a square, so it's actually x over 6 squared plus 36. If you work all this out and redistribute the 36 in there, you'll see that it's going to be the same. And so now here we'll do u substitution. U is going to be equal to x over 6, and then du is going to equal to 1/6 dx. And so the 1/6 can go as a factor of 6 outside, and so this whole thing will change. So the 6 as a factor outside will make this back into 1/6, and then this is going to be the integral of 1 over, and then now you have a u squared. Oops, we took out the 36. Sorry, this should have been a 1. So this is u squared plus 1. U squared plus 1. Oops. Let's try that again. U squared plus 1. And then du. So the 6 du, the 6 already went outside, and that canceled and made that into 1 over 6 instead of 1 over 36. And then we made our appropriate u substitutions. So now this is the arctan, and then we have a 1/6 outside. And then arctan of u, but u is equal to x over 6, so we might as well put that down here as well. And then we have a plus c. All right. So after all that, we have 1/6 arctan of x over 6, because we want everything back in terms of x's and not in u's. All right. So now let's just put it all together. We have those 3 integrals already. We have the ln of x minus 1. And then now there's a minus sign in between. We didn't worry about that because we were just taking a look at each individual piece of integral here. So now that we're putting it together, let's put those constants or the negative signs up. The next one is a 1/2 ln of and an absolute value x squared plus 36. And then our last one, again, we have a minus sign, and then we have the 1/6 arctan of x over 6. All right. So that took a little bit of effort. Oops, forgot my plus c. That took a little bit of effort, but I think we're all good. Nope, we're not all good. Oops, there's an equal sign. I think that should be a plus sign. One more time. Okay, so that's it. And it took a lot, and a lot of these things will take a lot of work because of setting up your partial fractions. And then sometimes the integrals might not be that simple either. So just be patient, and keep digging at the old material that you know and the new techniques of doing partial fractions. All right, good luck.